Hi everyone, welcome back. In this video today, I would like to show you the next part of the iteration. So far, we have learned iteration using substitution, iteration in general, and iteration using iteration by parts using substitution of U and V. So in this lesson today, you will learn a new thing, a new technique we call a partial fraction iteration. And why do we call a partial fraction? Because if you have a rational function as a fraction, you break it down, that fraction, into two fractions or three fractions, depending on the question. And you will break it down, and that's why we call them partial fractions. So you break it down, and then you iterate from there. So I have on the board on my right-hand side, I have wrote the summary of the partial fraction and how we do that. I would like to introduce the general idea first before I jump into the example. So if you just learn from me the example, you might not notice it. But if I lay it out first, and then at the end, if I try to summary it, then you will, for sure, you will remember better. But let's see how the concept of the partial fraction look like. So you will have case one when the denominator is the product of distinct linear factors. For example, you have 5x plus 1 divided by x minus 1 times x plus 2. So in this case, we call them linear factors because look at the denominator. Each of them in the linear form, degree 1. Linear form have x in the degree 1, and that's why we call a linear factor. Factor is just the product of these two brackets, right? So in this case, if you see the linear factors like this, with the degree 1, you will break the fraction into two fractions. On the top, you will substitute the numerator by a letter A, big capital A. Divide by the first denominator, adding with the big capital B, divided by the second denominator. And why we have a and B like that? The reason, because we don't know how we're going to put the number value on the top for the small fraction and this small fraction when we break it down. We know if we join them together, the numerator is 5x plus 1. So it means that whatever A here and whatever B here, the unknown number we don't know. We have to represent them by A and B. But we know that if we add the fraction, which is we do common denominator, it means this letter A will time with x plus 2, because at the bottom we have to time with this expression to get back to the same like this. So then the top we do the same. It's just like adding fraction common denominator. So you know that when you do that, the numerator of these two fractions here will be equal 5x plus 1. And then when we pair like that, we can solve for A and B. So that's how we factor them. We break them down, become a two small fraction, and we will proceed. So that's the first case. The second case, if the denominator is a repeated linear. So you see that this is x plus 2 power 2. It means they have two brackets multiplied together. So in this case, you still break down at a over x plus 2 for the first bracket. But the second bracket, you will keep the power as a power 2 rather than just power 1. So that's why you have to notice this is the case 2 to see how we do it. Now in case 3, if the denominator is irreducible. Now what do we mean irreducible? Reduce means you can factor and reduce them and simplify them. Irreducible means you cannot. So basically the word irreducible in here just the same like cannot be factored. So if you look at the the denominator in here, you have x squared plus 1 in the bracket here. This x squared plus 1 is the x squared plus 1. You cannot factor out for another expression. That's why it cannot be factored and you cannot irreducible. You cannot reduce further, okay? So in this case, if you see something like this, if the denominator is the irreducible factor, then you use ax plus b instead of just a like that or just b like that. You have to toss in an x in here as the expression ax plus b over this bracket because this denominator is irreducible. And then the next will be just follow the pattern c divided by the first bracket is x minus 1 to power 1. But the second will be keep as the power 2. So that is the case 3. Let's go through the last case, case 4. Case 4, you will use the case 4 when the numerator degree on the top and the degree at the bottom is equal. So you see this is x to square and this is x to square at the bottom. So their degree are the same, or the numerator is bigger than denominator. Let's say if the numerator is degree 3 and the denominator degree 1 or 2, then in that case you have to divide like a long division you learned already in the math 12. You use a polynomial long division and divide to get 1 in here. And then the rest you just follow the same procedure. Okay, so that gives you a general concept, but you're not gonna be understanding until I show you the example. However, I want to lay out like this so that it's clear, right, step by step for you to easy to follow my lesson. And when I put in the example and I indicated which case here I use and show you, then you will remember more easily and you don't mix up the patterns, right? It's very difficult when we don't know which pattern we use and how we mess it up. And that's why it becomes very difficult in math. So this is the way I laid out. I like this way because when I'm teaching, I give you example and I show you this is the case 1, this is the case 2 I use and how do I use it. Then it makes you remember more easily. Okay, so let's get right into the example. So I'm going to show you how. The first example, we will integrate 5x plus 1 over x minus 1 times with x plus 2. And of course, this will be dx. Now, when I do this, you will see what case we're going to use. Do we use case 1 or case 2 or case 3? Which one is matching? So we don't have we have a linear factor, right? So this should be like case 1. And I already put in the example here. So we're going to break this. equal, and I hope you can see the board. So that will become A, because I don't know what go on the top, over x minus 1, adding with B over x plus 2, and dx. Okay, it's not going to make you see the board very clearly. Okay, try. So now, obviously, you see that if I make this left side equal to the right side, I know that if I add these two fractions, I get back to this one here, right? The arrow go backward and forward because that's why we have an equal sign here. So to manipulate it, it means the first fraction, you have to time the first fraction with the common denominator x plus 2 here. So if the bottom here, you time with this to get back to this, then the top, you have to do the same, which is this bracket, you time with this, and you do the same for the top. And now, because I know the denominator is just the common denominator, we don't have anything to do with it. Our purpose is if we be able to solve for A and B, then we can substitute into the function. So therefore, I just focus on the numerator. But I have to base on the rule of fraction, which is when I add fraction, this have to time with this to get the same common denominator like this. It means I do the same for the top. So I'm going to say A time with x plus 2, A time with x plus 2, adding with B will time with this one, right? So the B will have to time with this one to get the common denominator. And I just write out the numerator for now. I ignore the denominator for a moment. So this is how it looks like. And once I do like this, I can say they do have a common denominator like this at the bottom, but the numerator will be equivalent to the top here, which is equivalent to 5x plus 1. So now, I hope that is clear to you, right? So now I'm going to distribute this. So I'm going to say A times x plus 2a plus b times x, which is bx minus b. This expression equal 5x plus 1. The numerator equal numerator, right? So now I factor out the common. I notice that the a here go with the x and the b here go with the x. So basically I can factor out the x common factor. I say a plus b times with x will be equal this 5x because that's the only term have an x in here. So it means this a plus b, I don't know what number are they, but I know when you add them, right, and you time with the x, you get 5x, which is equivalent to this. So now because they have an x and an x, and they multiply, I can bring this down, x divided by x equal 1, or I can just cancel it for now, and I know this become 1, right? So now I have a plus b equal 5. So I'm going to rewrite it. I'm going to say a plus b equal 5. So then the left of the expression here, 2a minus b, I have 2a minus b, which is no x expression. This is just a constant term. The constant term will pair with the constant term here. So this will be equal 1. So now I know 2a minus b equal 1. So I have two equations with two unknown. It means I be able to solve for it. So what I can do, I can add these two. I can add these two equations, right? This is number 1, this is number 2. I can add them together. So if I add them, I got 3a plus 0 minus b plus b is gone, equal 6. 1 add 5 equals 6. Divide both sides by 3, then I got a equal 6 divided by 3 is 2. So I got a equal 2. Now if I substitute back a equal 2 into this expression, then I solve for b. So I know a plus b equal 5. And a equal 2, so I substitute a by 2 plus b equal 5. Solve for this, I will get b equal 3. So now I know what a equal and what b equal. I substitute back into for the right hand side and I integrate it. So my a now is 2 on the top and bottom still x minus 1. And I'm going to separate them as well, right? And separate and integrate 1 by 1. b equal 3, bottom is x plus 2 dx. So integrate this will be 2 ln x minus 1 adding with 3 ln x plus 2 and plus c. So by separate them, I will integrate them very easily. Just apply the formula, right? This is the formula how to integrate the expression e to the x or ln exponential we learned already in the past, right? So that's how we done the first example. So I hope that now you understand a lot better. So in this case, we break this expression fraction in terms of partial fraction, 2 fraction, and we just apply. We solve for the a and the b. After we solve, we get the answer easily. Okay, so that is the first example. Now the second example will be a little bit harder. So I have to erase the bar to get into the second example for you to see. However, if you register to my online course, you have access to all of these notes and all of sample solution and the lecture notes like this. It will help you a lot to understand and follow the concept, right? So that's why I found online education is very good, qualified, because you can. Now I remember when I was in university, I had to listen and watch the professor at the same time, and it's very tough when you try to copy it out, and then you have to absorb and digest the concept at the same time. So if you stop to watch only, then you lost on the notes. And sometimes your friend doesn't have it and you could not borrow and you just lost it, and part of it you remember, part of it is gone, right? So make it learning become harder. Now if you listen, then you lose your notes. But if you don't watch, you try to copy it down, and sometimes they taught very fast, and you try to copy it down, and then you didn't get anything. You did not understand what's going on. So when I went home, I have to look at my notes again and try to figure it out on my own. Sometimes I could figure it out. Sometimes I lost the concept. I didn't know what's going on, to be honest with you. So that's why now I think online education, similar to tutoring one-on-one, however, it's a lot of more affordable, it's cheaper, and you can learn very well. Okay, so let me show you the second example. So the second example, let's say you have to integrate 6x plus 7 all of this over x plus 2 all of this square and dx. Now, in this case, you will see that the degree here is a degree 2. It's no longer linear, right? So which K we can use? We cannot use the first K anymore. Actually, now we have to use the case 1, which is when the denominator is repeated linear. Now, this is repeated linear because you have 2 brackets. If you break it down, you have 2 of them timed together. But however, this is different from the first K because the same expression, right? When you break it down, the same x plus 2 timed together. But the first one is linear, but they're not the same. One is 1, one is 2, x plus 2, x minus 1. So that's how you distinguish why we, in case 1, that's how we do, in case 2, what we should do, okay? So again, I'm going to break this, become 2 function, which is the top. I will have A. Now, if I break this down, is the first bracket will be the same, right? X plus 2. Then adding with the second bracket will be the same, x plus 2. However, the degree should be 2, just like that. So you break into 2 brackets. The first bracket is power 1, the second bracket power 2. Because this is power 2. That's all you have to do. And dx. So now we're going to use common denominator, which is A have to time with the same expression like that underneath here and up top as well. The B have to time with the nothing, right? Because you already have x plus 2 squared. So this B just time with 1 actually, right? Because this already is the highest degree and the highest, and this is already common denominator. So now I'm going to do the top here, right? I'm going to do in here. So we have A time with another bracket, x plus 2, adding with, and this should be iteration. No, let's just solve for A and B first. B time with nothing, and that equals 6x plus 7. So now I'm going to distribute. I have ax plus 2a plus b equals 6x plus 7. Now, it means I only have one term here, ax. Look like this term 6x because the 2a plus b is just a constant term, no x involved. So it means I can pair an ax here equals 6x. And x divided by x, or I can cancel them, which is I have a equal 6. So now I know my a. I'm going to solve for b. And solve for b, we have actually, if a equals 6 here, I have this is constant, so I have 2a plus b equals this constant, right? Because this is the constant term, equals 7. But I know a equals 6, so we say 2 times 6 plus b equals 7. So b will be equal 7 minus 2 times 6 is 12, and 7 minus 12 is minus 5. So I know b equal minus 5. Now I'm going to substitute back and solve for the integration. So my a is 6 on the top, underneath x plus 2 dx, subtract, this time b is negative, right? Or I just say and, but I also can separate them, minus 5 over x plus 2 on of this square. Now at this point, what will I do? This one is easy, right? Just like the first example we did, which is this one will be equal what? Will be equal 6 ln x plus 2. Unfortunately, the second one is complicated. There are no formula. So remember back in the previous lesson, you learned substitution by use. So So now I'm going to use the second one, right? I'm going to say let u equal x plus 2. So du will be equal 1 dx. And remember, we have a dx here. So now I'm going to say this will be equal minus 5 over u square integrate du. Now I'm going to bring the u up. So I got minus 5 u minus 2 du. So now I'm going to integrate this one will be equal minus 5. When I bring it out, I add 1 power, right? When I take it out, antiderivative, so that will give me u to minus 1, right? Also divide by minus 1. So that will give me minus divide minus is 5. And u minus 1, I'm going to bring it down, become u. So now I can substitute it. Let's see. And that for the second part will be equal 5 over u is x. I say let u equal x plus 2. So I substitute back x plus 2. So now I'm going to join with the first one, which is equal 6 ln x plus 2 adding with 5 over x plus 2. Let's see is our final answer. So this question is a combination of both partial fraction and substitution by u. So when we do perform the integration. So I hope you enjoyed. So we're not done yet. I will go through the third example. And the third example, you see it more interesting. Now, why I'm taking the time erase my board, you can relax your mind, right? And so that you don't feel so tired when you're watching the math going on. Because when you learn, you watch, even though you watch, you didn't do anything, but you have to try to focus, right? To understand what's going on. So the time when I erase the bar, it turned out to be useful time to help you to bring back the fresh air, relax your mind, right? Before we go to the next question. So I make excuse for my low high technology. However, that's true. I feel that. So now, again, all of these notes, if you register my course, you will have all of this to learn more easily, and you don't forget, right, when I raise the bar. Okay, so just bear with me, and we're gonna go to the third example. And each example will be slightly different and in the progressive level, harder a little bit each time, so that you can understand from simple to complex. Okay, so let's see what is our third example look like. Now, our third example, none of this is working. Our third example will be, so now I'm going to integrate from 3 to 4. This is not black ink, but I hope it's dark enough for you to see. X plus 4 divided by x minus 2 dx. Okay, so how we're going to do this? And what case we'll use? This is linear, right? Like the first case. But the only difference is, if you remember case 4, it says when numerator decrease the same like the denominator. So here, this is x to the power 1, x to the power 1. They same degree, they equal. Then we have to use divisor. So I'm going to divide x plus 4 by x minus 2, right? So remember long division, you have 1. 1 times x is just x. 1 times minus 2 is minus 2. Then you subtract both of them. You get 0 here. You get minus with minus become plus. Plus 2 and plus 4 is plus 6. So it means in this case, you will factor out this example, become the first one is a over x minus, no, sorry. The first one will be when you divide down, right? You get the first one equal 1. And if you put in integration, it's just 1 dx, right? Or you can put like this as well. You can say 1, adding with the second one is the 6 divided by x minus 2. Because this remainder have to keep divided by this, right? We're not done yet. And that's how it looks like. So now, easy, we can say this will be equal to x, right? Antiderivative of that. And don't forget, still 3 to 4. So x plus 6 ln x minus 2. And that's, okay. And this expression, we're going to evaluate from 3 to 4. So now, anything with the x, we substitute by 4. So that will give us 4 plus 6 ln 4 minus 2 is ln 2. Minus, let's take away this, x is 3. And sorry, adding with ln, no, adding with 6 ln x is 3, 3 minus 2 is 1. Now ln 1 equals 0. You key in the calculator, ln of 1 equals 0. So that turned out to be, this will gone, right? The whole thing will become 0. 4 minus 3 is 1. Add with 6 ln 2 is our answer for integrating this expression. Okay, now this seems that not too bad, right? Very quick. Okay, so now I will go through the 4 example. And for example, let's see, a little bit more exciting. We have integration of minus 2x plus 4 all of this over x squared plus 1 times with x minus 1 squared dx. Okay, so look at the 4 example. What do you think that we're going to use? Do we use case 1 or case 2 or case 3 or case 4? Okay, we do have an irreducible numerator, which is this one right here, right? Oh, I already show you here. Yeah. So this is how we're going to break this down, right? Because irreducible factor, numerator, denominator, right? And when we have an irreducible factor like this, we're going to use this expression for the first. So that will be equal a over x squared, and actually it should be ax plus b. We have to use this expression, x squared plus 1. adding with, now the next will be just the same. And because the letter B we already used in here, so now we have to go for C, right? And the next example, our next denominator will be just this. Adding with the D over, you see back into K1, case 2, right? Like that. X minus 1 to power 2. All of this will be the X. Okay? So now we have 3 fractions instead of just 2. So again, when we add them, we have to have the same common denominator. So what is our common denominator in here? It will be this one, x squared plus 1, times with this bracket, x minus 1, but to power 2, right? Not power 1 like that, right? We have to put in the highest degree when we do common denominator. So what does it tell us? It means the top here, I have to time with this bracket, right? To get the same common denominator. It means the top, I have to do same. So we'll say ax plus b have to time with this one. X minus 1 power square. And the C, I have to time with one more of this, right? Because I only have power 1. I need another one like that to make a power 2, right? But also have to time with that. So the C would time with x squared plus 1, which is this one here, time with one more of this because I already have x minus 1. So that's the C. Adding with the D now, I already have this bracket, so I just have to time with this to get common denominator. So x squared plus 1. That now I make common denominator, but I just ignore the denominator for now, right? I just work on the numerator. And I also ignore the integration sign just for a moment, right? So that I can handle with that. So now I'm going to multiply through. So ax plus b have to time with this bracket turn out to be x minus 1 times x minus 1 will be x squared minus 2x plus 1. It's a quadratic perfect square, right? I guess you already know. You multiply with not bracket, this is what you get, right? Adding with, I'm going to tie this through. No, actually, this bracket have to time with this bracket, right? So C time with x squared times x is x to the power 3. X squared times minus 1 is just minus x squared, right? Minus x squared plus x. 1 times x is just x. And 1 times minus 1 is minus 1. Okay. So the D, we just tie together, will be dx squared plus d. And all of this will be add up, become a top here, numerator here. Minus 2x plus 4. So now I'm going to distribute one more time, right? So now I'm going to do distribute one more time. So I'm going to time this together. I will have a x to the power 3 because x1 times x2, x3. This time this will be minus 2a x squared, right? x1 times x. And the last term will be just plus ax. Now I go for the next one. Next term will be plus bx squared. Times this will be minus 2bx. Time with this will be just plus b. Now I go to next C. So adding with cx3 minus cx squared plus cx minus c, right? I distribute 1 by 1. Okay, the last term will be plus dx squared plus d. Now all of this will be equal on the right hand side, which is minus 2x plus 4. So now let's see which one I can factor out. I'm going to pick up the like term, right? So I'm going to put x3 and cx3 together because they both the same like term, x to the power 3, right? So I'm going to say a plus c, all of this times with x to the power 3 will be equal 0. And that's true because we don't have, the numerator doesn't have an x to the power 3. So of course the term of x to the power 3 will be equal to 0, right? That's how it looks like. So I'm done with this one, this one. I'm going to do x squared. So I'm going to put 2 line as the x squared. We have cx squared, ax squared, bx squared, and dx squared, right? So I collect the like term and mark 2 line here. So I have minus, no, I'm going to put it down to another level, right? We have minus 2a adding with b minus c and plus d. This, all of this we time with x squared. And again, we don't have an x squared in the numerator, so this will be equal 0. So look like this is the first equation. The second equation, I mark it first 2, right? Now let's go to the third one. So the third one I'm talking about, put the dot on top. A times x, b times x, so this one, and this one, what else? This one, c times x. That's it, right? So now I have a adding with minus 2b actually, minus 2b, this one, adding with 1c, and all of this time with common x, right? X will be equal. Now we have it, minus 2x. So on the numerator, so this one will be equal to that. Okay, so this corner I mark as the third equation. What is our fourth equation? Our fourth equation is just the constant number, right? So what is our constant number? I'm going to check mark. B is one of them. We don't have A, right? B and C and D is 3 of them. Is a constant. So now I'm going to say B plus B minus C and plus D is the constant. And these constant add up will give us the constant term here equal 4. And I mark this as the fourth equation. So we have 4 unknown, A, B, C, D. And we have 4 equations. Now, as long as the number of unknown letters equal the number of the equation, then we'll be able to solve for it, right? Okay. But it will be a little bit tougher. So all of this will become my focus now to solve for A and B and C. So I'm going to put here. So now I'm going to just get rid of x to the power 3. We don't have that, but I know A plus C now will be equal to 0. That's my first equation. My second equation will be which one should I pick it? Okay, so maybe I just pick the second one. A minus 2b plus c will be equal minus 2, right? The x will cancel with the x here. So a minus 2b plus c will be equal minus 2. And this is the equation 3, right? Equation 4 will be b minus c plus d become 4. That's equation 4. What's our equation 2? Our equation 2 is more complicated. Minus 2a plus b minus c plus d, and that equals 0. Okay. So let's see what we can do. And that's equation 2. Let's see how we start first. So I'm going to focus on this, right? I'm going to have to erase the ball again so that I can continue with it. So this is 4 equation with 4 unknown, getting harder to solve, but be able to solve it. Okay, let's see how I'm going to isolate them and solve it. Now I have b minus c plus d, b minus c plus d equals 0. B minus c plus d equals 4. I can see that I can take advantage of these two equations right now. Because look, b minus c plus d, b minus c plus d, right? So this whole thing here equals 4. It means this whole thing here will be equal 4. So therefore, I say 2, equation 2, adding with equation 4 will give us what? We add minus 2a, right, this term, adding with, instead b minus c plus d, I'm going to say adding with 4, right, because b minus c plus d equals 4. And that will give us equals 0. So now we'll transfer over minus 2a will be equal minus 4. Therefore, a will be equal 4 divided by minus 4 divided by minus 2, it's just positive 2. So now we know a equals 2. Okay. So now we know a equals 2, we're going to use this, right? So we say from the equation 1, which is this 1, we're going to substitute a, right? So our a plus c equals 0. So we substitute a by 2. So 2 plus 0, no, 2 plus c equals 0. So what's that tell us? C will be equal, moreover, minus 2. So now we get the next answer. Okay, so now we know A, we know C. Let's use a 3. So now from the third equation, let me write down A minus 2B plus c equal minus 2. Now, a will substitute by 2. We know a equal 2. Minus 2b, just 2b, we don't know b. Plus c, our c is minus 2, so this will become minus 2. Equal minus 2, right? Follow the expression. Now we solve for b. So 2 minus 2 actually gone, right? So we have minus 2b equal minus 2. So divide both sides by minus 2, we get b equal 1. So now we know b equal 1. So now we have a, we have c, we have b. Now we have to find d. Now we're going to substitute back into equation 4. Equation 4 tells us that B minus C plus D equal 4. And B, we substitute B by 1. Minus C, we know C equal minus 2. So minus 2 plus D equal 4. So 1 plus 2 minus 2 become plus. So we have 3 plus D equal 4. So transfer over 4 minus 3, D equal 1, right? When I move this, it becomes minus 3. So 4 minus 3 is 1. So now we know all of them. So let's substitute back. What is our iteration at the beginning look like? We have minus 2x plus 4. All of this over x squared plus 1 times with x minus 1 to power 2 dx. So now we break it down, become this one here, right? Look at this one. So we have ax plus b. So we have ax plus b, right? Over x squared plus 1. Adding with c over x minus 1. Adding with d over x minus 1 squared dx. And this is dx. Okay. So now we're going to substitute a. What is our a? A 2. So we have 2 times x plus b. Our b equal 1. 2x plus 1 on top. Down here, x squared plus 1. And this is iteration. Okay. Adding our c, substitute c equal minus 2. Minus 2, all of this over x minus 1. dx. Adding with our d equal 1 over x minus 1, all of this square dx. Now at this point, you can use substitute point. Let's see what we can do about this expression. I think for the first iteration, I'm going to split it into two of them. So I'm going to say this will become 2x divided by x squared plus 1 and dx. Adding the second fraction, 1 over x squared plus 1 and dx. And adding with minus 2 over x minus 1 dx. Adding with 1 over x minus 1 squared dx. So now for the first one, I want to say let u equal x squared plus 1. So du will be equal to 2x dx. So it means I will substitute this. So therefore, the first iteration will be 1 over u, right? Let u equal this, yeah. Du. So 2x dx will become du. Okay. So now when we integrate this will become u to minus 1 on the top if I bring to minus 1. No, actually 1 over u is ln u, right? So that equal ln u and ln u, but we say u equal that. So it just equal ln x squared plus 1 when we substitute back, right? That equal ln u and u equal that. I substitute back. Okay, so that is done for the first one. Now the second ones, this is the formula we're supposed to use for the second one. So the first one will be equal ln x squared plus 1. Adding with the second one, we use this formula. 10 minus 1x on the top, so inverse of 10, right? That's the formula we can use. Then second one, the third one will be just minus 2 ln of x minus 1. Now we have to handle the last one. The last one, you can use u as well. So for the last, right, one, I will say let u equal x minus 1. So du equal dx. So that will give me the integration of 1 over u squared, right? Du. Yeah. So 1 over u squared, I can bring it to the top, become u to minus 2 on top. So adding to power 1 when we integrate, antiderivative will be minus 1. So this will give us at 1 minus 1. So u minus 1. And u minus 1 is just 1 over u. And 1 over u, and we say let u equal x minus 1. So just 1 x minus 1 plus c. Okay, so now we can write out the answer for all of them. So let's join all of them here will be ln x squared plus 1, adding with 10 minus 1x minus 2 ln x minus 1, and I'm going to connect this to here. So will be plus with 1 over x minus 1 plus c. So this is how our final answer for the integration of the whole thing. Okay, so at this point, I hope that you see what we're doing so far. You understand the lesson about the partial fractions integration. So the integration of partial fraction actually. This will be the last unit in the unit integration. Now stay tuned for the next unit will be area under the curve. So will be a lot more interesting stuff going on in calculus course 2. I hope you enjoyed my lesson today, and we'll see you in the next video. Thank you for watching. Bye for now.